The principles used to visualize lesions in 4D computed tomography can be used to inform one on how to make sense of life's contentious issues. Hi, I'm Adi van Rensburg and this is 4D Worldview. The question I am attempting to answer is how to decide what opinion to hold on the various contemporary philosophical dilemmas that we are all facing. I find it rather hard to unearth balanced discussion, and one usually ends up being bombarded by extreme opinions on polar opposite ends of the spectrum. To make matters worse, once you have viewed an opinion piece on one end of the scale, the AI search engines pushes you further in the same direction to the ultimate abyss. Let us look at how medical imaging tried to solve a similar situation and then see how we can use this to clarify our own positions. Let us consider a dense lesion in a patient's body, here represented by the dot in the ellipse. If we expose the body to an X-ray beam from above, like this, the lesion will cast a shadow. When an X-ray detector, like a film, is placed in the opposite side of the body, the shadow cast by the lesion shows up as a light spot on the film and can be detected. For a number of cases, this is sufficient, as we now not only know of the existence of the problem, but also of its approximate position and size. The necessary correction action can then be taken. This is analogous to those uncontentious issues where it does not matter who tells you of the problem. Everyone sees it in the same light and comes to a similar conclusion. Here is the first diagnostic X-ray of Röntgen's wife's hand. Note, here the shades are inverted with denser objects showing up darker due to the fact that it was a print made using an X-ray formed on a glass plate as the negative. This helps to easier interpret the image. Let us now consider a second, larger dense object lying directly above our lesion. The lesion will still cast the same shadow, but when we do the exposure, this small light spot will be masked by a bigger light area and would, for all practical purposes, have disappeared. Sometimes in life, we find that we either overlook a matter because we get tied up with other unrelated issues, or we cannot see the issue because it's shielded from view. Sometimes this is deliberate. This happens when one simply looks at life from one point of view. An obvious strategy to follow is to look from a different perspective. In our example, let us point the X-ray tube at the patient from below. It becomes quite clear though that this view does not help at all when we notice that after the exposure, the new image is almost just a mirror image of the anterior view. There is just a small difference in magnification. This is exactly what happens in life when one only listens to diametrically opposed points of view. In group politics, for example, the arguments on both sides sound similar, and one can often simply swap one group for another in the argument. It makes more sense to rather pick a lateral view for the second X-ray, as demonstrated here. In our example, we can now observe both entities separately, and the hidden lesion jumps out at the observer. This is analogous, in our previous group politics example, to viewing a certain issue not from one of the opposing groups, but rather through the eyes of an individual. Unfortunately, real life is more complicated than this, since the structure, more often than not, do not line up in such a simple way. To illustrate this, we can rotate the shielding structure slightly, and now both the AP and lateral views tell the same sorry tale. Of course, the observant amongst you will immediately propose the solution to rotate the X-ray tube until the two shadows are separated again. In the days of radiography, when only simple planar images were available, this was exactly the solution used for radiographs. There are voluminous handbooks written on which angle to use for the various conditions. Here are some examples from Positioning in Radiography by Casey Clark. What is important to note is that in order to interpret the images, one must know the exact point of view the images was taken from. This is of course something we often do consciously or subconsciously by first evaluating the source of an opinion before we consider the merit. This judgment is often based on frivolous aspects like looks or more considered matters like education or origin of the source. Now that we realize that the best way to find a lesion is to look at the problem from multiple angles, we are ready to explain how computed tomography works. Consider the same setup as before, but now instead of a film, we have a circle of detectors around the subject to be studied. The X-ray tube rotates around the subject. The lesion casts shadows on different places on the detector depending on the angle of incidence of the X-ray. In this animation, we show the results for every 30 degrees. We end up with a lot of information that is quite hard to interpret without some mathematical reconstruction. The simplest way to do the reconstruction is to back project the shadow to the X-ray source, as we know that the object must lie along that line. For this simple case, the resultant image looked more like a star than a dot. It is not clear in this simulation, but the intersection between the beams will be much darker than the individual lines. You will have to use a bit of imagination here. To get rid of the star artifact, one can of course erase the information on either side of the back projected line and repeat for each projection. This technique is called filtered back projection. The mathematics is best performed in the frequency domain using fast Fourier transforms, but this is a topic for another talk. Just indicate in the comments below if you would like to learn more about this topic. When done correctly, the final result is a good representation of reality. For simplicity's sake, think of it like this. If there is a shadow, we assign a positive number to it. The darker the shadow, the higher the number. The shadow for a circular object would look something like the orange curve. Now consider a sinusoidal function below. This function or filter can be used to convolute the shape. A simple animation would be to multiply this function by each value of the shape and then add them together, like this. The filtered shape can then be used for the back projection. Notice the negative values or erasures on either side of the simple shape. This will get rid of the star artifacts. Humans also filter information all the time, based on their own backgrounds and preferences. But just as using the wrong filter, or different filters for different views, can distort the image in computed tomography, the same can happen to the careless or lazy observer. One should take care to use the correct filter and to apply it in the same way to all points of view to prevent biased distortions. The description of computed tomography so far has concentrated on a two-dimensional plane, namely the transverse or actual plane, as indicated here. I have already mentioned that more than one slice can be acquired for a single revolution of the X-ray tube by having more than one row of detectors next to each other. Currently, up to 320 slices can be collected simultaneously. Of course, the other way one can collect more slices is to move the patient through the scanner. The latest generations of scanners do this in a continuous manner, thus the data is collected in a spiral fashion, which results in better image quality but a more challenging reconstruction. So, the third dimension is built up. The fourth dimension, of course, is time. The changes in anatomy can take place in various time frames. The simplest to understand is where the changes take place on a time frame much longer than the time needed for a single scan. And the changes can be observed by simply taking a series of similar scans and playing it back like a movie. However, it is possible to also freeze faster but periodic movements like the beating heart by using a time-based signal like the ECG. The data can then be sorted into bins corresponding to the various stages of the organ. In the case of the heart, systole or diastole. If enough data has been collected, there would be information for a full rotation for each bin or stage. And when this data is used for reconstruction, a movie of the beating heart can be made. This technique is called gated imaging. If you'd like to learn more about this, just leave a comment below. We are now in a position to look at how we may apply these principles on a human level. In the political sphere, one scheme would be to use a Nolan chart as illustrated here. In this instance, a two-dimensional plane is described where the one axis is economic freedom and the second axis is personal freedom. The prime purpose of this chart is intended to test where a person falls on the political spectrum, but we will see later how we can use it to inform us on what the best solution would be for a problem. Another example is the Pournelle chart, illustrated here, where the axes are statism, how much you like or dislike state interference, and rationalism, how much you like, dislike reason. For the purpose of this talk, I would like to use the three-dimensional Erickson NPOV chart, neutral point of view chart. Here the three axes are economic focus, societal focus, and governmental focus, with the values range now from community to individual. This, I think, can serve as an excellent departure point for us to implement the concept of a four-dimensional point of view. While the basic idea behind this chart is to explain the fundamental points of departure of the various political philosophies, we can use this three-dimensional space to inform us as to where the best possible solution for a problem can be found. In order for this to work, we have to open ourselves up to consider various points of view and to set our own personal biases aside. We should also consider that a single point of view cannot hold sway, and there must always be a compromise. It does not, however, imply that we will always end up in the center, but rather that the solution is almost never to be found at the extremes. Just as in the case for the 4D computed tomography, we don't know where to position the solution to a problem, but only have the solutions proposed by the different lobby groups. You must listen carefully to each opinion, know from which direction it comes on our 4D chart. It is of course problematic if one based the point of view or position of the opinion on the chart solely on looks. For example, if you look at me now in my Springbok rugby jersey, you may think that I'm a jock. But then my graduation photo for my physics PhD may tell a different story. When you see me in my South African Defence Force uniform, you may think I am conservative. But my campaign poster for the Democratic Party should plant some doubt in your mind. Care must therefore be taken to make sure that you listen to the opinion in detail and not just sound bites. And it is best if the direction is based on the narrator's own classification on his or her point of view. Once we know the opinions, we then have to weigh these opinions One way would be to assign a weight based on the number of individuals holding that opinion. Before we can then back project these data points to find the solution, however, we have to filter the data points. This is by far the most difficult step, as the application of a filter can have huge implications. One filter to use would be based on personal experience or a gut feeling. Another may take the financial implications of the solution into consideration, or simply raw emotions. I propose that the best way would be to use a filter based on the available scientific support for the proposed solution. Only after all these steps can we find a balanced, compromised solution. Please note that it would almost always be different from your own personal conviction. The fourth dimension of time is almost always neglected. In life and the world, nothing stays the same, and thus our solutions must adapt to stay relevant. Therefore, we too must be willing to change our minds. You cannot hold yourself to account for your own youthful opinions. There are, of course, also changes that take place on timescales that span multiple generations. And it is curious how modern trend is to criticize the very systems that put the critics in their privileged positions in the first place. I will follow this methodology to hopefully objectively and neutrally analyze issues in future talks. Before tackling these contentious issues, I want to first investigate logic, the scientific method, and how we end up with our individual belief systems. Stay tuned for more.